In this video, we are going to start talking about section 6.3, that is on working with normally distributed variables. Okay, so in this section, we are going to put together some of the work that we did in the previous sections, the techniques, and basically apply those techniques to word problems, essentially. So that brings us to procedure 6.1. In procedure 6.1, what we will be doing is determining percentages or probabilities, however you want to call it, for a normally distributed variable. Okay. All right. And so what we will do is, number one, when you do this, it helps to sketch the normal curve associated with the variable. Okay. So just draw a little picture. It doesn't have to be super accurate or anything, but a lot of times that picture will help you think through the problem. And then we're going to be finding percentages or probabilities. So those are going to be areas underneath the normal curve. So shade in the region of interest, the region that you're trying to find the area of, and that'll basically kind of be given to you in the problem. And mark its delimiting values, so the values that are on the edge of the region. And then find the z-scores for those delimiting values, and that's similar to the stuff that we did in section 6.2. And then use table 2 to find the area underneath the standard normal curve. Okay, and so essentially steps 3 and 4 are what we were doing, very similar to what we were doing in section 6.2. So none of that's really new. Okay, so when I work through these problems, I am going to go through procedure 6.1 and do it that way. That's the way that we would do it, sort of with using table 2. And then I'm going to turn around and show you how to do it on Desmos without table 2. Okay, you'll see that it's a lot easier on Desmos. Okay, so this is problem 6.90 from our book. A variable is normally distributed with mean 68 and standard deviation 10. So let me write that down so I can refer back to that. Okay, so 6. I'm just kind of adjusting. All right, so the mean is 68, and the standard deviation is 10. Okay, and part A, we want to find the probability or percentage of values that lie between 73 and 80. Okay. All right, so referring back to procedure 6.1. Right, the first step that we want to do is sketch the normal curve associated with the variable. So we're going to sketch that out. So it just kind of looks like this. And right here in the middle, the mean would be 68. I don't really want to write that because really we will be using the fact that the mean is 68, but really we want to focus on 73 and 80 here first. Okay. All right. Shade the region of interest and mark its delimiting values. So what they mean by that, right, is we want the region between 73 and 80. Remember, the mean will be right here in the middle at 68, and 73 will be somewhere over here to the right. So we're going to mark that. And again, this doesn't have to be super accurate. So 73 and 80 would be somewhere over here, right? More to the right. All right, so those are the delimiting values, the values that surround the region, right? And so we want to find the area of that little region right there. Okay. All right. So that is step 2. Step 3, find the z-scores for the delimiting values of x found in step 2. All right, so we would go and find the z-scores for 73 and 80. Okay, so remember for the z-scores, right, it's z equals x minus mu over sigma. And for us, we know that mu, right, is given to be 68. So it's going to be x minus 68 over sigma, which is 10. So that's our formula. And then we're just going to take 73 and plug it in here and take 80 and plug it in there. So z equals 73 minus 68 over 10. So 73 minus 68, that comes out to be 5, right? So we would have 5 over 10, which is a half. And then for 80, we would have 80 minus 68 all over 10. That is 12 over 10, which comes out to be 1.2. Okay. So we found the z-scores, right, for those two values. So that is step 3. And then use table 2 to find the area under the standard normal curve delimited by the z-scores found in step 3. So what we would do is now go to the standard normal distribution. Standard normal, right? And for the standard normal, we know that 0 is right here in the middle. And so what we would do is look at 0.5 and 1.2, right, on the standard normal. And that on the standard normal will be the same as this area on this other normal curve over here. Okay? There we go. Okay, so looking at table 2, right, what we're going to have to do is just like we did back in section 6.2, we're going to have to find the area to the left of 1.2. Let's see, maybe I can write that up above here. Because of the way that table 2 works, right, we need to look up areas that are to the left, right? So we're going to look up the area to the left of 1.2. Okay, so go over here to table 2. And that's a positive z-score, so we're going to be on the second page. 1.2 is right here. And then 0, right, is right here. So it's 0.8849. So let me write that down. 0.8849. Okay. Next up, we are going to look up the z-score for look up the area to the left of 0.5. In table 2, right? Because that's how table 2 works. All right, so 0.5, that would be right here. 0.6915. 6915. Okay, so we found those two, and so now to get this, the area of this region, the area of the region between 1.5 0.2 and 0.5, what we'll need to do is subtract, right? We want all the area to the left of 1.2, but not this area right over here. So it's going to be 0.8849 minus 0.6915. All right, so that's going to be what, 4, 3, 9, and 1, 0 point that. Let's just double check that, make sure it looks okay. Yes, that looks okay. All right, and so the answer on this is 0.1934. That's a probability, right, as a decimal. If you're going to write it as a percent, that would be 19.34%. So what you would say is that about 19.34% of all the observations lie within the range of 73 to 80, or the probability, if you did this experiment, that the variable would be, the value of the random variable would be between 73 and 80 is 0.1934. Okay, and then I'm about to erase this. Okay, and so then we will go back to our problem and take a look at our problem here and do part B. All right, so on part B, they want to know, right, what percentage of all possible values of the variable that are at least 75. Okay. All right, so going back here, our mean was 68, right? And our sigma was 10. Let's write that down. Okay, so number one, we need to sketch the graph, right? Okay, up here are at least 75. So remember, 68 is right in the middle. That's where the mean is, right? So 68 would be right here where the hump is. Okay, and so 75 is somewhere to the right. And if it's at least 75, that means it's 75 or bigger, right? So that would be this part right over here that we want to calculate the area of. Okay. All right. So then next up, we would calculate the z-score, right, of 75. So z equals x minus mu all over sigma. So z equals, in our case, right, x minus, our mu was 68. Our sigma was 10. All right, so that's what our formula for the z-scores will be. And what we want to do is find the z-score of 75, right? So we'll plug that in. So it'd be 75 minus 68 over 10. So that would be, what is that, 7 over 10, which is 0.7. Okay. All right, so what we would need to do then is to go look up in table 2, right, for the standard normal, the value for 0.7, right? And we would want to find the area to the right of 0.7 underneath the standard normal curve. Okay. All right, and so going to table 2, we're looking at 0.7, that's right here. And this is the area to the left, right, of 0.7. I'm just going to write that down. 0.7580. Okay. All right. Okay, so what we've got, right, just remembering back to 6.2, right, what we've got is, or what we just found, right, is that the area to the left, right, of 0.7 is 0.7580, right? But we want the area to the right because that's what the problem asked for, right? So what we'll need to do is just subtract that value from 1. So our answer, right, is going to be 1 minus 0.7580. That's the area to the right of 0.7, which is the same as the area of 75 on this one, right? And so we'll wind up with 0, 2, 4, 2. And just double check that. Yes, that looks good. Okay. And so that's the answer for this one. Okay, 0.2420. And so we would say that approximately, if you're looking at these as percentages, we would say that the percentage of all observations that would be bigger, 75 or bigger, would be 24.2%. Or if you're looking at a probability, you would say if we had did this experiment and looked at the variable x that we're looking at, the probability that the value would be 75 or bigger is 0.2420. Okay, it'll work here. All right, so on part C, we want at most 90. Okay, so at most 90. So drawing the picture, right, it would look like so. 90 would be way over here. Okay, and at most 90. So that means 90 or less, right? So we're talking about to the left of 90 over here. All right. Okay, so looking up the z-scores, right? We know the formula for z-scores is x minus mu over sigma. So x is, well, I want to wait on that. Mu is 68, right, our mean, and our standard deviation is 10. So that's our formula. And then we want the formula for 90, or the z-score for 90, rather. So we get 90 minus 68, so that would be 22 over 10, which is 2.2. So that would be the z-score for 90 for this problem. All right, so on the standard normal, we would be finding the area to the left of 2.2. If you're using table 2, well, that's the way table 2 works automatically. So all we have to do is look up 2.2 in the table. So that is this number right here, 0.9861. Okay. This number right here. And so in this case, that's the answer. There's nothing else that we have to do because table 2 gives us, right, that gives us the values that way. So no adjusting necessary on this one. Okay, all right. The next thing we want to talk about is the empirical rule for variables. The empirical rule, right, says that if I have any variable whose distribution is bell-shaped, and in particular, right, a normally distributed variable like the ones that we've been talking about, the following three properties hold, right? It says approximately 68% of all possible observations lie within one standard deviation to either side of the mean. That is between the mean minus sigma and the mean plus sigma. So I'm just going to go to the next slide here, right? And so if you look, because it shows a nice picture, so here's the mean, right? Remember, the mean is right where the hump is on the normal distribution. And so if you go to the mean plus sigma, that will be above the mean, and the mean minus sigma. And it says that about 68%, right, of the observations will lie in that range right here. Another way to think about that is that's about 68% of the area underneath the curve, okay? And about 95% of all possible observations lie in between two standard deviations, right? So 2 standard deviations above and 2 standard deviations below, right? Like this. So mu plus 2 sigma and mu minus 2 sigma over here. So if I take the mean and go 2 standard deviations above, 2 standard deviations below, right, then that region will have about 95% of all the area, or if you're thinking about it as outcomes, right, or observations, it will have about 95% of the observations will lie within that range. And so then also, if you go 3 standard deviations above the mean and 3 standard deviations below the mean, right, then we would expect that about 99.7%, right, percent of all possible observations lie there. So, okay, I think we're going to end this one here. And what we're going to do is move on to a different problem in the next video.